everyone, in this video we're going to look into chord-chord theorem, or this is otherwise called the angle of intersecting chords theorem. So let's go over this picture right here to better understand what do we mean by chord-chord theorem. So first, we are given two chords here. So we have chord AC and chord DB. These two chords are intersecting at a point inside the circle. So that's this point right here. And if they do intersect, we would be able to there's going to be an angle that can be created over here, which we will call this as angle X. Across angle X is its vertical angle. So these two angles are equal, and these other two angles are also equal, which is not equal to the other two. So since they're vertical, so these two angles right here would be equal. Now, after that, we also, on the circle, we also have what we call as, I colored it red. We call these two as intercepted arc. So the first intercepted arc would be arc AED, and the other intercepted arc is arc BFC. Now, there is a relationship between the angle formed and the measure of the intercepted arc, and that is what this chord theorem or chord-chord theorem or angle of intersecting chords theorem is all about. The statement for this theorem is that if two chords intersect inside the circle, so they're intersecting inside the circle, then the measure of the angle formed, measure of angle X, is 1/2 the sum of the measures of the arc intercepted by the angle. So these two arcs, the sum means that we add them up. So these two intercepted arcs shall be added, and we take half of it, and that would be the measure of this angle right here. So pretty much in this picture right here, we have the measure of angle X is actually equal to 1/2 of the sum of these two red intercepted arc. I created a word formula that would work for this. This formula that we have here works only for this specific triangle with all of it, this specific circle with all of its label, but this is the specific, this is the more general word equation for chord-chord theorem or angle of intersecting chords theorem. The angle measure is equal to half of the intercepted arc 1. So this is the first intercepted. You can actually switch it. It doesn't really matter because that's addition right there. So the sum of the two intercepted arcs. Now let's have let's have an example to better see how we use this equation right here. So let's take these two examples here. So I will put the formula up here because we're going to use that in solving for the missing value represented as letter X in this problem right here. So let's take the first example here. So we are given this circle here. We want to solve for X. Our X here is the angle, and these two 50 WE and this 174 which is VU are actually the intercepted arcs, and so this is the angle. So we plug these values into this equation right here. So we start with the angle, which is X. I'm gonna write X is equal to 1/2 of, then the first intercepted arc. Again, it doesn't really matter which one you write first. So, but I'm gonna write 50 first. So 50, and then that's degrees plus 174, which is the other intercepted arc. And so we add those two together first. So 50 plus 174 is 224. And so we take half of it. So the X here is 112. So this is the value for this angle right here. So this is gonna be 112 degrees. And that makes sense because if you add both of them and take half of it, and that's gonna be 112. At this time, I would encourage you to pause this video and solve for X. If you are done, unpause it and check your answer. Okay, so we go over the problem here. So it's pretty much the same thing. We have the formula over there. So we start with solving for the X. This is the X right here. So we start with the angles. Again, these are the intercepted arc. This is the other intercepted arc. And this is the angle. So be sure that we know which one is which. So we can go ahead and just plug it into the equation right there. So our angle here is 99. So I'm going to write 99 here. 99 is equal to 1/2 of, so that's the formula, intercepted arc 1. It doesn't matter which of these two intercepted arcs we would want to write first. It doesn't really matter because we're adding them. So I can go ahead and write the 63 first. So that's 63 plus, and then the other intercepted arc is x. I'm going to write x. Now the next thing that we're going to do is to get rid of the 1/2, or to get rid of the 2 here by multiplying both sides by 2. So I'm going to multiply this by 2. If I multiply this by 2, I do on the other side as well. So I'm going to multiply this by 2. So once we multiply by 2, we can cross these 2 out. So we're going to be left with 2 times 99 is 198. So that's 198 is equal to 63 plus x. So then from here, we can go ahead and subtract 63 from both sides. So subtract 63 here so that we can solve for x. So then our x value here is 135 degrees. So this angle right here is 135 degrees. Now, how do we know if we got the if our answer is correct? So we can go ahead and check. So I'm just gonna show the checking process over here. So we plug those values in. So we have 99 is the angle. We're not sure if that would be equal to. So I'm gonna put a question mark because we're not sure if they're equal yet. So we have 1/2 of the first intercepted arc. Again, you can put any of these. It doesn't really matter. But we're just going to write 135 first plus 63. So if we add those two together, so that would be 99. We're not sure of this one yet. That's half of 135 plus 63 is 198. And then from here, we take half of 198. That's actually equal to 99. So that means we are correct with our value for x, which is 135. Did you get the same answers as this? Good. Perfect. Now let's move on to the next problem right here. So this time around, we have expressions. So there are no angle measure in integer, but we have here expressions. So how do we solve for x and determine all the rest of the angles, the arcs and the angle? So again, we use the same formula up there. So I'm going to put that up there. So we're going to plug in values. So first, this FG is an intercepted arc. This EB is another intercepted arc. But this 15x minus 2 is our angle. So I'm going to put that in here. So that would be 15x minus 2 was the angle. And that is equal to 1/2 of the first intercepted arc. Again, it doesn't matter which one we write. So, but then I'm just going to write the one on the left first and go to the other one on the right. So that would be 16x plus 10. And then the other, so I'm going to plus add it to the other one is negative 2 plus 12x. So then from here, I can go ahead and distribute the plus to both terms inside the parentheses. And this would come out the same thing. So it's going to be 15x minus 2 is equal to 1/2 of, that's going to be 16x plus 10. Negative and positive would be a negative 2. And then positive and positive is a positive 12x. And then from here, we are going to combine like terms. So we can combine like terms here. First like term that we have is 16. And so I'm going to rewrite this one here first. So that's 15x minus 2 equals 1/2 of, we're simplifying it by combining like terms. So the first one that we got here is 16x plus 12x. And that would be 28x. So that's 28x. And then we're going to add the constant 10 minus 2 is a positive 8. So I'm going to write plus 8 here. And then we want to get rid of the 1/2. We can do that by multiplying both sides by 2. So if we multiply 2 to one side, we do the same thing on the other side. So I multiply 2. And so we can cross the 2 out. So we distribute the 2 to each of the terms inside the parentheses. That would come out 30x. So 2 times 15x is 30x minus 2 times 2 is 4 is equal to 28x plus 8. And then we want the x by itself. So we're going to combine like terms. So minus 28x minus 28x. So then we can cross the 28x here. And then so we're left with 2x minus 4 equals 8. And then from here, we're going to add 4 to both sides, plus 4 and plus 4. So then we are left with 2x is equal to 12. So then we divide both sides by 2. I divide this by 2 here. So I'm left with x is equal to 6. So our x is 6. Now we're going to put that in here. So x is 6. Now we are ready to solve for the rest of the parts. So we're going to start with FHG. So that's actually this angle right here. So what are we going to do is we plug this 6 into the x. So that would be 16 times the x that we got minus 2. Again, the x here was 6. So that is 16 times 6 is 96. No, 15. So it's supposed to be 15 times 6. That's 15 times 6 is 90. So it's going to be 90 minus 2 is 88. So this angle right here is 88 degrees. Now let's find the angle that we have here. So, I mean the arc measure that we have here. So that would be 16. And then we put in the x plus 10. Again, our x was 6. So 16 times 6 is 96. Plus 10 is, so this arc that we have here is 106 degrees. And then we move on to the other arc right here. So that would be negative 2 plus 12 times, then we put in the 6, which was the x. So that would be negative 2. 12 times 6 is 72. So that's a plus 72. So then this arc would be 70. So it's going to be 70 degrees. So angle FHG is 88. Arc FG is 106. And then we have arc EB is 70. And so let's check if we got the correct answer. To do that, we plug those values in. So instead of writing 16x plus 10, 15x minus 2, negative 2 plus 12x, we're going to write these red angles and, arc measures and angle. So we have 88 is the angle. So I'm going to write 88. So again, we are checking at this time. So 88, I'm still going to put a question mark. So I'm not sure if that would equal to the other side of the equation. So that would be 1/2 of the first arc is 106 plus the other arc is 70. So then we go ahead and add those two. So that would be 88. We're not sure of that one yet. So that's 1/2 of 176. So 1/2 of 176 is 88. So then 88 is equal to 88. So then our x is correct. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!